So, as hopefully you already know, we are here this evening to talk about Delta Lakes, and I want to give you an introduction to them. I want to give you an introduction to what we mean by a Delta Lake house and that play on words and what that actually means to us. So let's think about this then, and let's deal with some ambiguity firstly, maybe for my own silly humor, but we'll do it anyway. And the first thing I want to call out here is this point about Delta. What are we actually referring to? Well, once upon a time as data engineers, we absolutely thought about things when it came to the changes of records in our data processing. So to avoid any ambiguity, the first thing I'm going to say to you is that we are not talking about the delta of changed records since our last data process ran, which certainly when I've been in conversations with stakeholders and managers and things like that, that's probably a term that they're used to, you know, that delta of changes that come in from their source system. So we're not talking about that. We're also not talking about the fourth letter in the Greek alphabet, just in case there's any clever clogs out there that may be thinking that also. So there we go, ambiguity avoided. We are talking about Delta Lakes. The other thing to introduce you to as well, that the slides and the content for the session that I'm about to share with you, they are all available in my GitHub repository, the community events repo that's up there. And I think I put a subfolder in for the PASS hybrid group, because I got one in there by that convention already. So there's a PDF of the slides and the code and the things that I'm about to show you is already up there as well. Good, and I'll share that link at the end. So let's kick off then. Now this is an introduction session, and it pained me for a while to think about what should really go into this introduction session, because it needed to be very much about Delta Lake, of course, and what it was and how we got there. So I felt compelled to perhaps go a bit theoretical to begin with, but for good cause, because the reason for this and why Delta Lake becomes important to us as data engineers and as data analytics people is the ability to use tables for whatever we need when we're getting that data insight from our source systems for our customers typically. So there's a bit of theory in here, but I think it's theory that's necessary to really paint that picture for this introduction to what our Delta Lake now is. So I'm going to start with part 1.0. A bit of background, a bit of context, and then ultimately the problem that has now been solved by this. And hopefully that gives you a good starting point for where we go next. So let's kick off with a bit of background. And the background we want to talk about is acid. Who likes acid? Now, ambiguity again. We are not talking about acid that you might find in the science lab or indeed my wife's cooking. Not that sort of acid. The sort of acid, recreational drugs, is that the sort of acid we're talking about? No, of course not. I'm just being stupid again. Not this sort of acid. The sort of acid that we're interested in is that we find when we think about computer science. Autonomicity, consistency, isolation, durability. So it's that acronym, it's that type of acid that we're interested in. And specifically this acid, when we think about it in the context of our database transactions. So hopefully we're all database people, and it's this acid that we apply to our database transactions that, you know, you can go through this wiki article if you wish, but it gives us that guaranteed data validity is the important part. And this is something that we've been used to for a while. So as you heard in that introduction, I've been working with databases for a very long time, and they're great. I like them. Our database management system, our DBMS, as we'll call it. And with that principle, with that acid that we get with our databases, there is a lot of maturity and a lot of stuff that we can then do. So to name a few, I've circled here with our database, we can do all sorts of stuff with schemas and self-describing tables and indexes and abstractions and upserts, you know, you name it. It's not new here. It is mature technology. And these databases with that acid backing, you know, now come in all different shapes and sizes, all different flavors. You can have elephant flavored databases. You can have sea lion flavored databases. You know, it's all good. And I started life playing with SQL Server databases and Sybase and Oracle. So this was good, and we liked our databases because of this ACID that they came with, and that those database transactions ultimately. And then we got thinking, and we thought, well, what is better than one database? The correct answer being two databases. Two databases are better than one, obviously. And this is where we thought, okay, well, what shall we use that second database for? And the answer was creating a data warehouse. So maybe a little bit theoretical here, but on the left-hand side, we have our online transactional processing database, or our application database. And on the right-hand side, we have what I like to call our offline analytical transactions, or our data warehouse. Offline in the sense that it is offline from those transactions that are coming in from that live front-end system maybe. And as data engineers, we did this thing called extract, transform, and load, which was good because it meant that from our data warehouse, we could then create those dashboards, we could get those insights. And if we're going to overuse Wikipedia here, we can look at what a data warehouse is and get that definition. And what we find, of course, is a system for reporting and data analysis, which, yeah, great. So that was good, and life was good, and we were happy, and we had our two databases, our online, our offline, and we were okay. Then along came a data lake. And, we thought, okay, this could help. And we started looking at our data lake, and we started looking at our data lake in the context of our database. All of those things and all of that good stuff that we got from our database, we started thinking about, and what we ultimately found is that our data lake fell short. A lot of that stuff that we were used to having available to us was not there in our data lake. Now, what it did offer in the context of big data, the buzzword that is, it did offer big data support in the sense of those 4 V's, the volume, variety, velocity, and veracity. And okay, that was fine. So it did solve that fairly crucial need that we had as data volumes were skyrocketing, basically. When it came to multi-processing, if we think about that, then yes, we did get that, but it came in the form of scalability, scaling out ultimately, distributing that storage across more storage nodes than we previously had available. So this was, it was a good thing. When it came to data structure, responding to what's one of those V's there with the variety, then absolutely our data lake could handle that. Our structured, semi-structured, our unstructured data, thinking about images and blobs and JSON or XML as our semi-structured data there. So absolutely our data lake gave us that ability. And then lastly, through abstraction mainly from the vendor, we did get a lot of redundancy baked into that as well, particularly when using platform as a service technology delivered by a cloud vendor or something. But ultimately, we missed our ACID, as did Jip from the film Human Trafficker I mentioned earlier. So to kind of summarize and really sort of frame that problem then, when it comes to our data lakes, what I'm going to say here is that data lakes are good, but they still lack some of that basic ACID functionality needed for data processing, particularly people like ourselves that are maybe doing data engineering to ultimately perform analytics from our source system, etc. And what I'm also going to say here is in the sort of the gray line that maybe we're actually trying to use data lakes for everything to replace our databases, which of course is wrong. That's not what our data lakes are for. And in my table, I'm going to just call out just a few fundamental differences about limitations and resilience and things like that, which falls in line with that ACID set of properties that we want. But then the last one I'm going to call out and say, well, think about now the storage and the compute, because as data volumes increased, we ultimately found this need that we had to distribute things, we had to scale out. Our SQL Server database, let's say, that could basically only scale up in terms of adding CPU power and RAM and things to it, you could obviously get very clever and creative with file groups. And some SAN guys were talking to me many moons ago, the storage admins, and they were doing all sorts of weird and wonderful things that was over my head. But it meant that nevertheless, the storage and the compute in our databases was very much coupled together. Now, of course, the appeal with our data lakes was that the storage was now completely separate, decoupled, and computer science people love things to be decoupled. So, we lose that cohesion maybe. So that was very much our problem, if you like, that our data lakes were missing that ACID, but they did obviously have some appeal that was very attractive about the technology. So let's kind of enter then the solution. Now, ultimately, in the very sort of generic, simplified way I'm talking about, the solution is perhaps obvious. We just need to enable ACID transactional support for our data lakes. So if we think about it very simply of the storage, which in the most case of our data lakes is some form of Hadoop and distributed file system underneath, then the compute that we actually want to bring in is, for all intents and purposes now, going to be some flavor of Spark. So the solution is, yes, enabling that ACID transactional support, but if we think about how, and that how really is about using that compute with that storage in a way that we were perhaps used to doing in our DBMS, our database management system, but that was wrapped up as one product. Now, these things that are very much decoupled, we need to bring them together again. I'm not going to say that they're tightly coupled. They're still very much decoupled, but I'm going to say that they're now working together as friends. And that is ultimately the solution that we need for our data lakes. So with that then, let's be a little more specific then. Let's go a little deeper into the technology. Now, lots of industries, lots of companies recognize this problem, and Databricks, as hopefully we can gather where this talk is leading, created Delta Lake. Our friends at Netflix created Iceberg, and Uber created Apache Hudi. So these are all ACID frameworks that will sit over a data lake to give us that good stuff that we need. Now, I don't work for Netflix and I don't work for Uber. So of course, I'm very much going to focus on the Databricks implementation of this acidity, if it's okay to call it that. And Databricks made Data Lake or Databricks Delta available at GA in February 2019. But they actually then went one further, which I think was a bit of a game changer. And what they did was that they took that Delta Lake, that Delta capability, and they ultimately open sourced it. So in April of 2019, Ali was doing the keynote at the Spark and AI Summit, as it was called then. And the announcement there was very much that Databricks have taken that Delta Lake or that Delta capability. They've open sourced it now as a project called Delta Lake, which was great, which now meant that actually for any Spark implementation, we could take this open source code project and we could use it to gain those transactional properties that we so badly needed over our data lake. So to answer that question very directly, and to quote from the Databricks blog, Delta Lake is an open source storage layer that brings ACID transactions to Apache Spark for big data workloads. Now, the big data workloads part is maybe a bit contentious there, but it's that's the answer to that problem that I framed earlier. It's that transactional support over our data lakes. Now, I'm a Microsoft person, I'm an MVP, so I have a Microsoft bias. So when I'm coming to implement this for my customers, I'm very much going to be thinking about it in Azure. And what have we got within Azure available to do this? Now, of course, the obvious things are that we have a Databricks implementation. So Databricks now, although they open sourced their Delta Lake project, they still have their own offering, their own implementation of Apache Spark, with its premium features and lots of good stuff within that Databricks environment. We, of course, also have a Microsoft implementation of it. So Microsoft can just as easily take Spark. They can, wrap it up for us and then can apply it. They can install the Delta Lake libraries, which is actually very hard to do, by the way, and they can deliver it to us within Azure, not just through Databricks, but available to us now through Synapse Analytics, through Data Factory, and through HD Insight as well, if you want, which is great because, we now get a whole lot of versatility with this ability to create what is really a very simple concept of a database table, but now, with this distributed compute, with this distributed storage. So that's all good. And I think what's going to be really interesting is that where we have these superpowers, let's say, that have taken this open source implementation, they've added their own magic and things to it, is where they now actually might start contributing back to that open source version. That's going to be really interesting, particularly in the new world of Microsoft, where they like to open source things, which I think is brilliant. So perhaps to answer the question that's probably on the top of your minds right now, which Spark implementation is better? Now, I don't have an answer to this one, but I'm going to use a film reference again to play on it for a moment. I'm going to say that this is very much like taking the red pill or the blue pill. I'm going to say, in this case, that Spark and Delta Lake, they are Morpheus, and I'll be Neo in the scenario of, which Spark implementation am I going to use for a given architecture, for a given solution. And we'll play on this film reference. What you may have noticed is that this morning I asked this question on Twitter, for your Delta Lake implementations, which are you going to do? Are you going to go blue or red? And if you have a look and you follow me on Twitter, there's some fairly interesting answers to that from, very respectable people in the industry of what they've now done. But, this is where the landscape is changing. We know we want distributed compute. We know we want distributed storage, but then which vendor do we go with? And because Databricks did the great thing of open sourcing the Delta Lake project, it means that as people on the receiving end of it, there's no vendor lock-in here. There's no cloud lock-in, if you like. There's very little risk in terms of a particular technology that you use. So you've got that freedom, which is all good. So we'll probably play on this as I go through the rest of this talk, and we'll think about it a bit more. But for now, which Spark implementation is better? No idea. Let's wait and see. Let's see what they come up with next, because both of these superpowers are developing some really great stuff. Anyway, we're here to think about Delta Lake and to go a little deeper with our Delta Lake and what it gives us. If we're working in Azure, we have our storage and our compute. And it's that transaction log that I just want to go a little deeper in now and introduce you to. So, we really have a good understanding of what's going on here when we actually start working with this stuff. So I'm going to take the red pill for this scenario. I've got my Databricks implementation, and I've got a Azure Data Lake Gen 2 with its hierarchical namespaces. Now, when I want to create a table, a Delta table, or what we could crudely think of as a database table way back when, what we find in our storage layer is a folder, which will be labeled with the table name that we've created. And we will now get the transaction log, which will go into a subfolder _delta_log. And that transaction log on disk will be written as JSON files, and JSON files that we can look at, we can inspect. And I tried to simplify one here so we could show it in a slide, but I appreciate it's perhaps quite small and not that easy to read. But this transaction log, just to highlight some of the action words on here, it's readable. We can understand it. We can see that there was a commit, that there was some metadata, that we can see the structure of the table that we're creating through this. And that's nice. So, we we can see what's in that transaction log, that very important transaction log that gives us that ACID properties and that capability. And if you're not a fan of looking at the JSON, here's a simplified version of what those action items in that transaction log actually mean from the Databricks blog again. So, have a look at that and be mindful of it. Now, what's also good is that, with this transaction log, you think, well, JSON's not the most efficient thing to be reading every time that you want to interact with one of these tables. Absolutely. Very true. And certainly, as you have more and more transactions, this transaction log will grow and grow. And as database people, we can appreciate that that's inefficient. So what you'll find in here, if you're looking at the disk, looking at the storage, that after the 10th transaction file that's been created, we will also get a checkpoint file. And all of the transactions that have come before it then get consolidated into a Parquet file. And we also get an untyped last checkpoint file as well, which gives a pointer to which Parquet file we should then go and use to get all of the transactions before it. So this is good. We can work with this. We can understand this. So that's our transaction log. If we then think about what else we have on disk in our Delta table, depending on how we partition our data, I've gone for a very simple example here of year, month, day, which I think is quite common. We'll have folder structures and child folders for that separation of year, month, and day. I've simplified it here, but we will then have a set of subfolders under that table name that contain our actual data. And those will be represented using the open source standard, which I think we're probably all familiar with now as Parquet files. So depending on how our batches are actually running and how we're working with our data, we might end up with a file per transaction line, maybe. Obviously very inefficient, not perhaps what we want to do. Or, if we've got a big batch operation, we can write that as one file and we can do things on the right to say, yes, I want this to be improved. And as our data volumes grow, we'll get more and more of these Parquet files that represent our data for, say, a given partition. Now, what's really nice about this as well, if we think about performance, we can do something called optimize here. Now, if you've taken the red pill, that's great. We can use optimize, although it's spelt wrong. But we can then consolidate all of those small Parquet files into one large Parquet file, which, as you can appreciate, is far better to hit than trying to scrape data from lots of small ones. So that's a nice feature of our data lake, our Delta Lake as well. And things that we've really just come to expect in the maturity of our database management systems, we now have these equivalent operations over our storage and using this compute here in certainly a cloud environment, in this distributed environment as well. Now, the other nice thing as well, if we wish, we can do something that's called vacuum, also spelt wrong. We seem to have a problem with spelling and grammar these days. I know I do on a personal note, but hey ho, it seems that we can't name things correctly spelled either, but that's fine. We can live with that. So we can vacuum these files as well. If we want to say at this given point in time, if I've done some optimization work or I've got some small files, I want to get rid of them, I can perform a vacuum and they can be deleted as well. So all good. So just to summarize, when we think about our Delta Lake and, playing on that definition that I quoted earlier, that storage layer that sits on top of our data lake that gives us that ACID capability. What we have in there in that storage layer, we've got our transaction logs in JSON for the most part, and we've got our data as Parquet files. So great, that's what our Delta Lake looks like on disk. Then if we turn our attention to the compute side, now there's not really too much to say here because this isn't an introduction to Databricks. So I'm going to cheat and kind of skip over it a little bit, because really what I'm going to say to you is that if you're used to working with Databricks, nothing really changes for you. The only thing that you'll see that's different, if you look at this cheat sheet that I've got a link at the end in the references for you, is that in the syntax, we're just now from our data frames writing a different format. And that format is Delta. So we can use that when we're doing our usual data frame operations. We can use it in our Spark streaming jobs as well. It's just that different format of Delta that we need to reference. And then everything else is taken care of for us. So brilliant. Certainly in Databricks land, nothing really changes here. We just get all of that good stuff with very little change in our code. Now that was the Python cheat sheet, as I'm sure you probably saw. I'm more of a SQL person than a Python person, certainly. And I've got the SQL cheat sheet here as well, as you can see. And the thing to call out, if we've taken that red pill, that at the moment we can also write a SQL merge statement in the same way that certainly I've been used to when working with SQL Server in a more of an on-premises, say traditional type warehouse or whatever. A T-SQL merge statement, we can now write an equivalent Spark SQL merge statement using that understanding of those Delta tables and achieve the same thing over our data lake. Now, that's a really big deal for me, because once upon a time when we first started, or I first started working in Azure, it was very much CSV files. And there was no real concept of doing a row level upsert. It just wasn't possible. It was more of a delete and rebuild of everything that was there was how you did it. So to have this merge statement, this merge capability, this upsert capability is brilliant over those Delta tables. Okay. So just changing gears again then and trying to honor what I wrote in my abstract for this session. If we now think about what I've told you so far with our databases, our ACID transactional properties over those tables, and just to address head on that play on words of what we now mean by a lakehouse. So I showed you this slide earlier, and I said we have our OLTP system, we have our OATP system on the right, and we've got our data warehouse. So thinking about this, thinking about our data warehouse, playing on the words, we go from our data warehouse to our lakehouse. Okay, I'll do it one more time for you because we love animations in PowerPoint. Lakehouse. And it is that data lake storage. In my case, we're going to use the Delta Lake standard implemented via some flavor of Spark, probably Databricks at the moment. And then we can achieve our lakehouse if we wish. And that's it. That's all we need to think about. Tables that exist in our data lake. And because we love Wikipedia articles, we also have the lakehouse starring Sandra Bullock and Keanu Reeves. Nothing to do with it. But hey, we had to include some more film references. Good. Okay. Enough of the theory then. Show me this, Paul. Let's see it in practice, because theory's boring. Okay, I will. I'm just in a room talking to myself. All good fun. I've not even got the webcam on. You can't even see that I'm smiling and being playful. So for this demo and to introduce you to it, I thought, well, what can I actually show you? It's an introduction session, so how basic or how boring can we go? Because hopefully as professionals in this industry and as data engineers, we're very used to querying a table. And we could say, well, that's all our Delta Lake gives us, the ability to query a table. I thought, well, no, we need to do better than that. I can't just show these people querying a table because they know how to do that already. So what I'm going to try and do with this demo is introduce Delta Lakes, and I'm not going to talk about all of the exciting things that you can do with a Delta Lake table, things like time travel and some of those optimized capabilities, because there's lots of content out there and that's the exciting stuff that's probably already been done to death. I'm more interested in sort of real world practicalities and how versatile these tables can be, particularly when we're architecting a solution. So that's kind of the script I've given myself, and that's the thing that I want to address for you in this demo. That sort of real world practical versatility, not some of the fun marketing stuff that you can go and find lots of demos on and examples of. So To start with my real world demo, I'm going to take the blue pill. And what I want to do is just to call out in Synapse something that's quite handy, certainly if we're introducing this. And I'm just going to show you going to the Synapse Knowledge Center, and we can browse the gallery. We can type in here Delta in capitals because we're going to shout about it. And we can go to our notebooks. And what you'll find in the Synapse Knowledge Center is that we can get some examples here, getting started with Delta Lake. Great, let's do that. If you want to go to your pipelines, you can deal with Delta copying, which is very much that thing I talked about of those Delta of changes. So not that. We don't want to do that. We want to go to our notebooks. And another great thing is that within Synapse, if I took the blue pill, I can use this notebook. I can use it with C#. So what Microsoft have done with .NET for Spark. And I'm very much a T-SQL C# person in the beginning. So being able to write C# now over Spark is something that's actually quite attractive. I'm not going to go through this notebook. I just wanted to kind of show you as a good starting point that you might want to go and have a look at, because there's all sorts of things in here where the data is totally irrelevant and pointless, but what you're seeing with some of this code, if you choose this version or the Python version, is some really good examples of how lots of transactions are being written to a Delta table, lots of Parquet files that are being created there, and how you do things with them. And there's an example of a Spark streaming job in this notebook as well. So go and check that out firstly. I thought it was something that was worth calling out. Now, for my example, let's just get this Spark session started. Yes, I'm aware that you've timed out. Thank you. What I'm going to show you is that in my data lake, so sticking with Synapse for the moment, and in the data lake that I've got attached to my Spark workspace, I've got a container that I've called Lakehouse. And in here, I've got two folders. I'm calling one raw, and I've used these data sets before. I think they came from the AdventureWorks database once upon a time, and I seem to have used them over and over in lots of my talks, but I have order headers and order details lines, which you can probably guess what the contents of those contain. So let's work with those Parquet files as my sample data. And my Spark pool within Synapse has now started, or it's trying to. I did tell it not to auto pause and just stay running, but apparently it didn't want to do that for me. And let's just clear the decks just to make sure things are nice and clean so we don't have any issues. I'm using Shift and Enter on my keyboard, by the way, if you can hear me banging that in the background, which is the new F5. Do not press F5 in a browser window because that will refresh the page. You don't want that to happen when you're trying to execute code. You do want to go Shift and Enter, and I'm telling you basically to bake it into my own muscle memory. So let's start by doing something very simple of just reading that first Parquet file. Nothing exciting here at this point, and just proving what data we've got in there, which hopefully no. And let's just kick off the cell below it as well. So that doesn't look very good, does it? But with our order headers, we've got our sales order ID, and we've got some stuff in here, not very interesting. And our order details lines, we've got some order lines. Good. Now, what I want to do is that within that storage, I'm going to now just take those Parquet files and write them out to Delta Lake tables instead. So I've got a tables directory, nothing in it. Wrong refresh, that refresh. Make sure you use the right refresh. So format Delta mode overwrite, but they're not there already, so it's fine. And then I'm just going to write out those two Delta tables, which means we can then start doing something fun with it. So we've done that, and now if I look at my storage, hit the right refresh button, you'll see what I described to you in the slides is that we have a order details table. So we've got that top level folder for the Delta table. And now I've got the subfolder for the Delta log. And in here, we've got, in this case, just a single transaction file. So just my one JSON file, which we can preview, although it's not very friendly to preview it like this, but we can kind of get a feel for what's going off in here. We've got our commit, we've got our metadata, we can see the schema. So we've got the fields, we've got that sales order field is the first one. It's a type of integer, it's nullable, so we can kind of understand what's going off with the transaction log. But we've just got one of them because we've only got one write. And that one write has created that one Parquet file, which you'll see very much in this format. Now, if I'd told it to partition it or use a particular column to do the partitioning, which you can see in the transaction log, you would get those subfolders in here as well. In my case, I've just done a single write of that order details line, and so that's all I've got. So nothing too fancy, very simple, and the same for the order headers. So those are my Delta tables created. That's as hard as it gets. But what I'm going to do now is I'm going to create a database. Now, a database in this context, when I'm using the Spark pool, this is a Hive Metastore database at this point. So if I look at my data and I look at the data in my workspace, if I just refresh here, I've now created a table, a database called Lakehouse, and you'll notice that it's a Spark database. And in that Spark database, there's nothing in there. And I'm going to say to it, actually, in my Hive Metastore, I want to have those Delta tables available to me as well. Because once they're in the Hive Metastore, I can start writing that Spark SQL against them, and I can work with them. So I've kind of just wrapped up that SQL in a bit of Python just to execute it with that SQL context, really just so I can pass in that base file path at the top there. You could have written the SQL straight away here if you wish. Nevertheless, so I've done that. Now, unfortunately, we can't see the columns in our Hive Metastore for our Delta table at this point, but hopefully that's something that will be addressed in the future. But what it does mean is that now I can come in here, I can use my magic, my double percentage signs, and we can do what I promised in this basic demo of doing select star from, look at the IntelliSense go, from my Lakehouse database against my order header details. Wow, I was quite impressed by that IntelliSense. I've not seen it come up that quickly. And we get that most basic of things of being able to write a SQL query against a table. But you appreciate now the abstraction of what this Delta Lake is giving us. Good stuff. So we can then take it one further, and let's do that's slightly more basic of things of joining those two tables together. I've put an aggregation here, this time on the order lines for the sales order number. I don't need to tell you what the SQL's doing, and I've put a having clause on it. So I get the results. It's all good. This is nice. I can even have it as a chart if I want in this fairly rich notebook experience. Great. And then lastly, I'm going to say, fine, actually, let's create that as a view. So a view within my Hive Metastore as well, which sadly don't appear in the Spark database. But if I query the view directly, we get the same thing. All good. So I took the blue pill. I did some very basic things, nothing that exciting, but I'm now working with those Delta tables that exist on disk. And I just happen to be using that Spark pool within Synapse, which is all good. Now, to try and offer you some insight into, just the versatility here, if I'm going to interact with my Synapse workspace, one other type of compute that we do get available to us is this serverless SQL endpoint, as it's currently called. And if you copy the host name and the path here, this on-demand SQL instance, and you load up Management Studio, we can connect to it, as you see I did earlier, and we can interact with it very much like a SQL instance. Now, you'll see that there's some metadata sharing here between that Hive metastore and what we've got within the SQL instance. And, if we just think about, well, what's going off here? If we do a version, we see just an Azure SQL instance, so nothing too fancy. But you'll see that I've got my Lakehouse database there. That Lakehouse database that when I was in my Synapse workspace was referred to as Spark. So I thought, okay, well, is this really a SQL database? So if we just do a version on that, then, apparently it is. So you think, okay, well, let's just do a create table on here, and let's call it dbo dot, can't type today, things, and let's have an ID column in there that's an integer. But we can't do that. Create tables not supported. Okay then, fine, I accept, I'm not too bothered. But within this on-demand SQL instance, we can do other stuff. So what I'm going to do is bring on a set of queries, as in, here's some I made earlier. And I'm going to use this, what I've called this serverless Lakehouse. And let's make sure I'm using that, because I always forget. But what we can now do within here, if I've not done it already, I can't remember, is, it does already exist. We can create an external data source. Interesting side note that I think I seem to have been so used to looking at notebooks with executing code that when I come to Management Studio and I'm now faced with a big set of white space and a blank canvas for writing code, I need to separate it now to give me that cell effect from used to writing notebooks. I don't know if you probably share the same views here. Maybe it's just me, but my brain can't seem to cope now unless I've got cells for my code. Whereas before I used to hate cells, I just wanted it all as a query. Anyway, shut up, Paul, you're rambling. So what we can now do is with that external data source is, as you can see from the SQL, I can now write T-SQL over my Delta Lake. It can understand those Delta entities. It can use that transaction log. And I'm going to select top 10 from my order headers. I can do the same from my order details lines. You get the idea. Now, interestingly, what I can't do at this point is create an external table, because that says it's missing the file format. And if I give it the file format of Delta, then it doesn't like that either, but I can't do that at the moment, and that's fine. I'm within the serverless pool here, so I'll accept some limitations. What I can do, however, is for whatever the red squiggly lines are saying to me, because I'm doing the create statement, it wants to execute it on its own, not with anything else in the transaction. I can create some views. So within my serverless Lakehouse database on my Synapse serverless pool, I can create a view in T-SQL over those Delta tables. Great. I can do the same sort of aggregation type thing. Maybe it's a little bit slower, but hey ho, it's possible. We get the results. And I can create, let me just put an or alter in there because I seem to have forgotten it because I can't remember what I did earlier. So you can see I've now got that aggregated view over this as well. So I've now basically achieved the same thing in T-SQL that I showed you that I'd achieved in Spark SQL. So it's that versatility. So it's that ability to now query these Delta tables using that serverless pool, which I imagine from a cost perspective, having that serverless cluster there is probably going to be far nicer for some people, and interacting with a T-SQL endpoint, which, pretty much all things can interact with a T-SQL endpoint or a SQL Server instance, because that's all it is. It's just abstracted away. So good, there's another example of what we can do if we take the blue pill. Now we think, well, okay, I don't want to take the blue pill, Paul. That's fine. You're okay in doing so. I want to take the red pill. I want to use Databricks instead. think, yes, fine, we can do that. So my small cluster has started. Thankfully, I'd have to wait for it. And I can now go into a Databricks notebook instead. And let's just see if this is already mounted. I can press Shift and Enter to execute in here as well now. I don't know when they added that, but I think I did it by accident the other day and was surprised because it used to be Control and Enter. But hey ho, all good. You can still use Control and Enter as well. So I'm going to mount some storage because my compute is very much separate. It's obviously a little more connected within the Synapse environment. And hopefully this is just going to tell me that it's, oh yeah, I unmount it just to make sure. And then let's mount it again. I'll have another sip of my water while Spark's thinking about it. Come on, Spark, I've only got 8 minutes left here. What are you playing at? Good, mounted. So let's just have a quick list of the contents. And, we can look ahead a little bit here. I don't necessarily think I need to execute everything. I'm basically just achieving the same thing. Because those Delta tables, they are using that open source standard. It doesn't matter which compute I hit them with. I hit them with the Spark implementation via Synapse. I hit them with the serverless implementation via Synapse. And now I can hit them with the Databricks implementation of Spark as well. So I'm just bringing my own compute to the storage and using it. And perhaps the bigger point is that the data is staying where it was created. I'm not moving it around. And certainly for big data, I don't want to move it around because that's an expensive thing to do. I'm leaving it where it is and working with it where it is, using the compute that I want. So achieve the same thing, as you can see from my queries. Hitting the order header, I put it in a database called Lakehouse again. So this lives now in the Hive Metastore attached to my Databricks cluster, as opposed to the Hive Metastore attached to my Synapse Spark pool. And same sort of aggregation. I should have just left the results, shouldn't I? And I'm creating a view in the same way for that same aggregation and creating a graph as well, because we love doing stuff like that in notebooks. Now, that's all good. So the last point I'll make is that if we wanted to interact with both these things, maybe in Power BI, we could go away, we could get data. We could say, I want to get data when it loads in Azure from an Azure SQL database, and I can hit that SQL serverless pool. I can say, actually use the Databricks connector and interact with my Databricks compute. Now I can do both, and both are going to take me to that Delta table storage. And just to prove it, here's one I made earlier with my fantastic Power BI visualization skills. James Dales has nothing on me when it comes to Power BI visualizations. Make sure you tell him. So there's my blue visuals coming from my SQL on demand. I can't bother to wait for the red ones. Let's have a look at the model, if you like. So I've got different data sources in here. I've got one, as I've said, coming from the SQL serverless pool, just to prove it, if you like. Sorry, that's gone off screen a little bit, but it doesn't matter. Let's just do advanced editor. So you can see the M from Synapse, because it's just interacting with it like a SQL endpoint, nothing too fancy. And then the same thing from Databricks. I do advanced editor as well. I've got the M now hitting it with the Databricks connector. The Databricks connector actually is very good, far better than the Spark connector, because it will start the cluster for you as well. And if I wish, I can do the same thing. I can join my blue order header with my red order line detail. I can perform that same sort of aggregation in the visual. And of course, as we know, blue and red makes purple. So I've got a purple visual on here as well. So nothing too fancy, but really just to sort of open your eyes to the art of the possible. Okay. Now, very last thing I'll show you, because we are in the theme of versatility, is that if I want to perform that same aggregation now in Data Factory, I can, because our data flows can now interact with a Delta table they can interact with them in line. So I don't need to create a data set in here. I just need to point it at the storage. I can use the data flow Spark implementation. I could perform the same join. I could perform the same aggregation, and I could create an output of a Delta table with that aggregation as well. Do make sure if you're using data flows with Delta that you go to the Delta options, which is hidden down here. It's got a nice little one that says auto compact, and I'll leave you to inspect the optimized capabilities that auto compact gives you via a Data Factory data flow. But the point, versatility, is hopefully you'll agree. So enough of me clicking around in there. Let's just come back to the slides and wrap up. So with a few minutes to spare, the last thing I wanted to say to you, and my final thoughts here, because it's all well and good having this new technology and this very versatile compute that I've shown you, but what else? And I started thinking about this very much in the context of our Lambda and our Kappa architectures. So if you're not familiar with what these things are, there's a great Microsoft Docs page out there where we think about a big data architecture is having these basic things in it, in these blue boxes. Our storage, our processing, our stream processing, and our analytics layer, and some orchestration as well. And in our Lambda architecture, we separated that batch and that speed layer. In our Kappa architecture, we tend to unify the technology and have the batch and the speed layer together. So I started thinking about that very much in the context of what these Delta tables now give us. And once upon a time, in the days of Nathan Mars, we could say that we were doing this very much with our Hadoop and our Storm technologies. Then using the old Azure icons very deliberately, pre-Delta Lake, we were doing this with our data lake analytics and with our SQL data warehouse, as it was known. But actually now, with the implementation of these Delta tables, are we actually now moving all towards Kappa architectures anyway? Because we can handle both batch and speed data in here at the same time with the same compute, and we don't need to do anything. The red flavor, of course, and the blue flavor as well. So the last thing I'd like to ask you, if the chat's available and if we do fastest finger first, what I'm going to say to you is that if we think about our Delta Lake and our lake houses, and we've got them there, and we've got ultimately what is our dashboard or some insights that we want to get from it, and we've got some Spark implementation. You know, at that point, we could be very cloud agnostic where that dotted blue line is. It could be AWS, it could be Azure, it doesn't matter. The principles apply. Now, do we go directly? Do we go more traditional and say, I want a T-SQL relational layer and a semantic layer via analysis services? Do we go via that SQL database that we've loaded from our Delta Lake, because we're moving the compute and the heavy lifting to the left in our scaled out cluster, but then we're serving it with a more traditional scaled up SQL database with perhaps a subset of facts and dimensions? Do we go via Synapse and say, I've got a Spark pool here, or a serverless pool, or even a full fat SQL pool, and do we serve Power BI that way? Or do we just go via Databricks? So given what I've shown you, given that versatility, and thinking about now consuming our lakehouse in Azure, what would you go for? Options 1, 2, 3, 4, 5, 6, based on what I've described. And if you want to do fastest finger first in the chat, I'll be interested to know your answers. So there's no wrong answer either to it as well, by the way. So fastest fingers, good. 5s, 5 or 3s, 5, 5, 5s. Databricks all the way, sure. Azure SQL DB or Synapse Serverless, yeah, fine. Number 1, Ian Pike likes number 1, with a winky face, might add. It's fine. I like red pills, that's fine. Good. Okay, thank you for indulging me. So these are obviously things that you can now figure out, hopefully, with this introduction of what I've now given you for these Delta Lakes. And what I've put in the slides as well is a whole bunch of reference material, including Mr. Whiteley's YouTube channel, which has got a lot of great content on it as well, but don't tell him I said so. So with that, I will say thank you everybody for listening. Thank you for taking the time this evening. And the slides are in my GitHub repo, the community events one, and my contact details here. So thanks a lot.
Great stuff. So straight to the questions, Paul.
Yes, I put my camera on now.
So, if you want it, the only problem with that is we'll have to see your lovely face for the next 10-15 minutes, which is clearly a good thing. So, my Alexa just decided to turn on. Maybe she's objecting about my sarcasm. Anyway, let's go straight to questions. So there's been a little bit of confusion, I think, from a few people in chat about I think the confusion really relates to, you know, Delta Lake and data lake houses, and we've got one here about Delta Lake House. So I will ask you this one question we've got about it, but if you could also maybe expand to those that are slightly confused about the data lake house architecture, just to explain it. So I'll ask you the question first. So Satya says, what do I need to do to make a Delta Lake into a lake house? I kind of struggle to understand what I need to aim for lake house, as I already have a Delta Lake in place. Thanks.
Okay. Yeah, good question. I think let me put this slide back up and skip through the animations. So if you have a Delta Lake implementation, you have a lake house in essence. It's the marketing people, I think, that have done their job of confusing us all again. Databricks created Delta, so they called it Databricks Delta. That was fine, and that was what it was in the beginning when it went GA within Databricks. That was in February 2019. Databricks then open sourced the Delta capability, and that project was called Delta Lake. So Delta Lake is the open source project that Databricks made available, which came from Databricks Delta. Now, what Databricks have since done is perhaps a little bit of a rename, and they've now said that thinking more about our data warehouse requirements, what they've said is that we're now going to call it a lake house. So this for me is very much a Databricks term using Databricks Delta, but with the purpose of creating a data warehouse, which they've called a lake house. So as far as we're concerned, it's a table. The storage is a data lake. It has a transaction log. Now, what we do to implement that with storage and compute and which vendors we use don't care. It's the same thing. So hopefully that clarifies it. It's just the terminology the marketing people, I think, have used, I'm going to say, is the problem there.
Cool. So Johannes is asking a question. Is the JSON transaction log not very big? It has no compression.
Is it not very big? I mean, the transaction log is as big as many transactions that you add to it, right? So, and the compression comes when you checkpoint it and it gets consolidated into a Parquet file.
Okay, so when it gets consolidated to the Parquet, the log gets truncated.
The log will still exist if you're doing things like the time travel capabilities and that other fun stuff that you get in there. So there may still be parts of it that remain. It's not like a truncate operation. Think of it as always adding to it.
Paul, isn't I could be wrong in saying this, but I thought Delta Lake is using Snappy behind the scenes, so it's automatically compressing, isn't it, the JSON? Yeah.
Sorry, yeah. I was thinking more about the truncation and the compression, but yeah, absolutely.
Yeah, I think that's what Johannes was kind of alluding to, you know, because we've got quite big unstructured or semi-structured data. I think he was quite concerned that the transaction log would get humongous. Okay, so Johannes wins the prize for having asked the most questions today, so everyone will need to bear with us a little bit. But it's a good thing, Johannes. We'll give you a prize if we can find something. So the question is, as Delta is all per file, how does Delta perform with lots of joins? As Delta is aiming for big data, how does Delta perform with small data?
I think it's like any of these distributed systems, right? You get a high entry point, but then say very linear scaling. And if you're working with small data, maybe that high entry point of that distributed compute isn't for you. You know, maybe if it's small data, you want to deal with a technology that scales up where, that the entry point is much lower. So I think it's that trade-off. It's using the right tool for the right job. And maybe to answer the question directly, how does Delta Lake and how does this distributed compute work with small data? You'd probably say, well, badly, but it scales linearly as that data volume increases because of the high entry point.
Good. Next question, also from Johannes. He found no decent end user tools on Windows to inspect Parquet files. Can you recommend something? And on a side note, Steve answered that there is a free Parquet viewer for Windows. It isn't exactly feature rich, and they often end up exporting data out and use something else to view the Parquet files. And that would be my opinion as well, to get some kind of export or create a table and look at the end result of the Parquet files.
Yeah,
what do you say?
Yeah, great question. There is a Parquet viewer in the Windows Store, which I don't think is particularly well supported anymore. So I'm just trying to find so I do it justice. So I don't use the one in the Windows Store anymore. I'll put it on screen for you. Hopefully you can see that. In this person's GitHub repo, they've got a Parquet viewer that they wrote in C#. And because I like C#, I was quite happy to download that source code and actually compile it myself. And I made a few tweaks to it as well. So this is a Parquet viewer that I would use within Windows. Again, not necessarily a industry standard one, but this is the one that I tend to work with. But yeah,
Perfect.
great question.
So we can even write our own now, can't we, using that code as our source?
Yeah, you could if you wish. Yeah. I mean, because the one in the Windows Store, I think some of the comments and the reviews on it put me off installing it. Whereas with this one, because it was C# and I could actually download it and compile it myself, I was a little happier with what was happening.
So we go from a good question to a stupid question, and we know it's a stupid question because it's one that I've made up for you.
Oh,
so if I have completely new data that arrives in Parquet files onto my data lake that I want to add into my Delta Lake, must I upsert these through Spark SQL, or can I just land them into my Delta Lake directories?
You cannot land them directly into your Delta Lake directories. You will need to read that Parquet file in as a data frame and then do some sort of operation to upsert it into the Delta table, or create or write that Parquet file back to your data lake as a Delta table first, and then work with it in that way. So, thank you for the stupid question. Maybe not.
Sharuya asked the question, can we query Delta Lake with SQL pools, do joins and stuff? And any kind of SQL pool.
Yeah, great question. So I don't know the answer, but one thing that's just kind of reminded me that I should have called out was the Synapse thing that I showed you earlier. Query Delta. Is that the querying Delta tables using the serverless pool it's still a preview feature at the moment. So obviously Microsoft are working in this space and adding more and more support for interacting with those Delta tables. I've not tried creating an external table with a full fat SQL pool or a SQL data warehouse, as I think we can call it.
Yeah,
So I don't
the
know.
general consensus, including my own, is that dedicated pools doesn't currently support Delta.
Yeah, I didn't think it did. And yeah,
Yeah.
it reminded me that the other version is still preview as well. So, but you can obviously create an external table for a Parquet file. So if you're using a SQL pool, then maybe you want to just work with the Parquet file and you don't want to use Delta tables at all. It depends on your use case.
So moving swiftly on, Johannes, you're back. So I actually think this is quite a good question as well. In a data warehouse, surrogate keys are very important. What kind of approach do you recommend to generate surrogate keys for your Delta data?
I feel like somebody added this on Twitter earlier as well, actually.
Oh.
So the pattern that I currently adopt is that it's a hard one, absolutely, because we don't want to be using GUIDs and things to resolve the foreign keys for our facts and our dimensions, because that's just not going to perform well at all. So the pattern, the approach I would currently take is, if we get to that eventual serving layer where we're surfacing a star schema where facts and dimensions are the intention, hopefully very narrow fact tables as well, but whatever, I will read the Delta table in Databricks, let's say, keep that work in memory, keep Databricks doing the heavy lifting, if you like, write out the dimensions firstly to say a SQL DB, so we get that auto incrementing ID, because that's what SQL's good at the end of the day. Then once we have that auto incrementing ID there for our dimensions, we start then building our fact tables, again using Databricks, keeping it in memory. So Databricks doing the heavy lifting, and Databricks will then read the dimensional data set back from the SQL table and resolve those foreign keys for the dimensional data sets, and then write out the fact table. So that's kind of the pattern and the approach that I would work with at the moment. Certainly not perfect, certainly feels like a few extra steps and hops there, but that's probably the least bad way of getting those integer values that we want for doing our joins when we get to say our semantic layer.
So I think we've got two more questions. So if Mikkel, if you want to go for this next one.
Yes, we have Harinath asked the question if we can create functions and stored procedures in a lakehouse.
Functions and stored procedures in a lakehouse. I'll say no directly to answer the question, because when we think about functions and stored procedures, they're obviously just wrappers for our code, if you like, which very much sit on the compute side. So it's not something that's really going to be persisted in the storage, that code. So really then it comes down to what computer we're using. And if, say, we're using the SQL serverless pools like I demonstrated, then I think the answer is still no. I'm going to just go and try it, because it was no, I think, last time I tried. I'm not going to do it. I'll do it on my other screen.
I think serverless, you might be able to do stored procedures and views. I don't know about functions. Yeah,
I've not tried functions for a while. I mean, it's still obviously emerging technology, but I would say, what is a stored procedure going to do for you in your lakehouse that you can't just save as a notebook? It's just a wrapper for that code. Is a stored procedure really giving you much value there? Why not just have it as a notebook?
The one suggestion I've had for stored procedures and views is just as acting as a security boundary. So it's just, gives you a bit more granular security, which may be valid. Okay, so we're going to move on. We've kind of got a last minute one from Satya, but I don't know if you want to do that one, Mikkel, but I'll just speak about Martin Tenev has asked the question about partitioned Delta tables with Synapse. He seemed to believe there used to be a problem with reading partitioned Delta tables. Is I presume that if that did exist, it doesn't anymore?
Yeah, I've not seen that problem.
Yeah,
So
me neither. Yeah.
I'm going to assume it may be since Synapse went GA last December, they've sorted that.
Do you want to do the red pill one
Yeah.
then, Miguel?
Satya asks, if red pill is the choice, that will be Databricks. What would you recommend for lineage? Any recommendations?
Sorry,
Lineage.
lineage.
Yeah.
Sorry, my Swinglish.
No, it's fine.
You said it correct in Swedish.
Yeah.
What would I recommend for data lineage? What to, I guess, documentation and things like that. Yeah, interesting question. I don't have a good answer at the moment because data cataloging and things seems to be a challenge for lots of vendors and lots of reasons. At the moment, I've been playing around with Purview, as I'm sure lots of people have. I've been looking at Calibra and Informatica for these things. For my data factory processing framework, I even created my own data lineage diagrams using the metadata and yeah, just rendering some stuff in Markdown. Perhaps the interesting one that I have not played with yet is Databricks' Unity catalog, which was something that was announced at the Data and AI Summit this year. Yeah, it must have been this year. Yeah, July of this year. But yeah, I don't have a good answer yet. That whole cataloging and lineage piece is an interesting one. I don't know at this point.
Cool. That would be the conclusion of the questions. And a thank you to everybody who joined us today, and a big thanks to Paul.
Thank you.